I'm going to walk through a quick molar calculation, and this one is going to be the combustion of magnesium with oxygen in the atmosphere. So magnesium plus oxygen goes to magnesium oxide, MgO, and you'll notice that this is not balanced yet. We have two oxygens here, so I need to balance these things out. And we do that by putting a 2 here, but now we have two magnesiums, so I need two magnesiums here as well. And so it's balanced. Now, let's suppose we're told that you have 1 kilogram of magnesium, and you're going to burn it in the air to produce magnesium oxide. Would be a white powder. How much, let's try and figure out how much oxygen that's going to use up in the air, assuming we have an unlimited amount of oxygen to burn. So this is my mass rho. I'm also going to want to know my RFMs and my number of moles. So let's go through this one at a time. So the RFM for simply magnesium Mg, look at my periodic table, that is 24. Oxygen is 16, but there's 2 of them, so that's 32. And MgO, that's just going to be 24 plus an oxygen, so plus a 16. So that's going to be 40. And now this question of the number of moles. How many moles do we have here? We can only answer that for this one. And just remember, when we're working with moles, we always convert to grams. So this is 1,000 grams, not just 1. And the equation we're going to use, remember, whenever you have the same number of grams of a substance as its atomic mass, or its RFM, that's 1 mole. So the number of moles is equal to mass divided by the RFM. So in this case, we're going to have 1,000 grams of magnesium divided by 24. So we do 1,000 divided by 24. I know I need a new calculator. Is 41.67. 41.67 moles of magnesium. Just an extremely large number of magnesium atoms. Okay, so what's next? Well, now that we know how many moles of magnesium we have, we can actually fill in how many moles we have of oxygen and how many moles we have for magnesium oxide, because we can come up here and look at the balancing numbers. 2, 1, technically speaking, 1, and 2. And so these balancing numbers tell us the ratio for these mole numbers. So for example, if this represents 2 parts, this would represent 1 part. So 41.67 divided by 2 is 20.8. 20.8. Whereas these two are both a 2, so they're going to be the same, 41.67 moles of magnesium oxide as well. And now we're ready to figure out the mass that goes here. And we're just going to rearrange our equation and say that mass is equal to the number of moles times the RFM. So number of moles is 20.8, and the RFM is 32 for oxygen, so we do times 32. And our mass is very sinister, 666.7 grams. And just for completeness, let's also do this one over here. So remember, mass is number of moles times RFM. So we're going to do number of moles, 41.67, multiplied by 40. And this gives us 1,666.8. So you'll notice that, in fact, these numbers add to give this number, give or take a tiny rounding error there. That's because chemical reactions conserve mass. Nothing gets lost ultimately. It's just a rearranging of atoms that were originally here and then rearranged to make a different compound.